Okay. So last time we have studied till the basic properties of fluid. Today we are going to deal with one branch of physics. That branch is known as hydrostatics. So mainly the hydrostatic means what? We are going to study about the fluids which are at rest. So fluid which are at rest, we are going to study about that. In that, first we are going to study about the pressure. When the fluid are at rest, what happens to pressure? Now normally you know from 11th standard, you know one standard formula for pressure. That is pressure P is nothing but force per unit area. Now what is this force that we are going to see? Suppose say this is my container containing fluid. And if I want to calculate the force exerted by this fluid on the bottom of this container, so if I take a unit surface area A of this container, so the force which will act normally on this surface area A will give me the pressure P. Means what? The normal force acting on unit surface area A gives me the pressure P. So it has SI unit. By formula only, you can calculate the SI unit. Force has unit Newton and area has unit meter square. So Newton meter square is my SI unit for pressure. And one more other unit is there, which is given by the name of the scientist, known as Pascal. Now this is your SI unit of pressure. But when you are trying to measure the pressure of gas, there is one other unit known as torque. So these are the important things related to pressure. One thing even I want to tell you, that anything which is having a small weight and small surface area can give or exert a higher pressure. For example, if you take a balloon, and with the forehand you try to compensate, you have to burst it. So you will apply a force equally from all these sides, right? Okay, it will burst after some time or it will take some higher efforts. But if instead of bursting it with a forehand, if I take a needle, a small needle having a small weight and a small surface area on which my pressure is exerted, it will burst quickly. It means what? The object having small weight, and small surface area can exert a higher pressure. So always remember, the object which is having small weight and small surface area can exert a higher pressure. So I hope this pressure topic is very much clear to you. Now, as we are talking about the hydrostatics, that is a fluid at rest, let's see if I take a container containing a fluid which is at rest, how much pressure is exerted. So, for that, we are having one topic in our textbook, that is your 12th standard textbook. The topic name is pressure exerted by liquid column. So pressure exerted by liquid column. So if you want to calculate the pressure exerted by liquid column, let's have a container filled with liquid. Outside there is a air. Suppose say I am saying the liquid is water. Having some density rho. Now here I will take an imaginary liquid column. Imaginary means it's totally imaginary. I am imagining just like this is one of the liquid column from this whole fluid I am selecting. So this is one imaginary liquid column that I am taking, having the area A and height h. Now what do you want to calculate? The pressure exerted by liquid column. Means whatever I am considering this imaginary liquid column, I need to calculate what amount of pressure it is exerting on the bottom of your beaker. So it will have some weight as it is there column, so it will have some weight mg, which will act toward the bottom of your container, right? So for calculating pressure, the normal formula is force per unit area. Force exerted by this liquid column will be nothing but its weight, and that is nothing but mg. So instead of F, I will write m into g is nothing but the weight, and this is nothing but the force acted by this liquid column on surface area A. Now, mass. This can be written in other form. Means you know, density is written as mass upon volume, right? So mass can be written as density into volume. Again, volume can be written as, we are considering only the volume of this imaginary liquid column. So if I want to write the volume of this imaginary liquid column, I can write A into H. So A into H will give me a total volume of this imaginary liquid column. So rho, instead of V, I will write A into H. Now, as I get M here, I will insert here. So my this equation will be P is equal to, instead of M, I am having now rho A H. So rho A H. G as it is upon A. As you can see, in numerator and denominator we are having A common, so it will cancel out. And last we will get P is nothing but H rho G. So this is the pressure exerted by liquid column at the bottom surface. Now the main thing here that should be noticed is that pressure is always dependent on the height and density of liquid. It does not depend on the area. So the main thing that should be noted down here, that pressure is always dependent on the height and density of your fluid or liquid. I hope this topic is much clear for you now. As we are studying now about pressure, my next topic for you is atmospheric pressure. Till now we have seen about the atmospheric pressure many things. Means we have seen the layers, right? Ionosphere, troposphere and many more. But the small topic in your textbook, they have mentioned that what is atmospheric pressure and what happens as we increase the height. So, my next topic is atmospheric pressure. So see, your whole atmosphere contains of air, and of course air will have some weight. Suppose like previously how I have considered imaginary liquid column, same way I can consider imaginary air column. It will have its weight. It will exert some pressure on any object, and that pressure will be known as atmospheric pressure. Now the things to be remembered in this topic by a 12th point of view is, always remember, if I take a sea, this is the surface of your sea. So always at the surface of your sea level, your atmospheric pressure is high. As you go above from your surface of your sea level, your atmospheric pressure start decreasing. At certain height, say 8 km, your atmospheric pressure becomes less. And if you try to go above that, you will get inert gases, which will create a gas pressure. Because of inert gases, the gas pressure is created. So, at the point where your gas pressure is less than your atmospheric pressure, that space is known as vacuum. Or in other words, you can say vacuum is the thing where no matter is present. So, if someone will ask you, what do you mean by normal atmospheric pressure? Then your answer should be that at the sea level, your pressure is high. Which atmospheric pressure? So at the surface of sea level, whatever the pressure is there, that I will call as normal atmospheric pressure. Above that, as you go on increasing the height, your air becomes less dense. Means density of air goes on decreasing, and In same way, atmospheric pressure start decreasing. At certain height, it is zero. And above that you have your inert gases. Because of inert gases, whatever the pressure is created is known as gas pressure. As your gas pressure is less than your atmospheric pressure, that region is known as vacuum. Or in other words, I can say vacuum is the region where no matter is present. So these are the few things that should be remembered by a 12th point of view. In your topic, in your textbook, we are having this topic. So whatever the main things that should be focused that I have mentioned here. I hope this topic is clear to you. Thank you.